a little hurry, right? So then immediately we have to send to you to the class. So then I just hurriedly completed this IP address. But again, you have information, then automatically you have to read. But what is the very important? Right? Use explanation is different. Okay, stick points are different, right? So IP addresses, IP address classes. Okay, so uptake, so which is we discussed yesterday. So here it is: class A, class B, class D, class E. Class E is R&D type, means we are not using, we can't assign IP address to, we can't assign an IP address to a device. We can't assign an IP address to a device from class D and class E. That is important. We cannot assign. And also we cannot assign 0 series, 127 series also, 169.254 series also we can't assign. 0.0.0 is reserved IP address for certain services like a default routing, some certain process it will be used, but we cannot assign to any adapter, any device. And every PC has their own IP address. Every PC having a their own local IP address is there, that is called a 127.0.0.1 without NIC or with NIC, but every PC has its own name, its local host. The IP address is 127.0.0.1, and of course 127, the entire series is we are not using, that is used for a special loopback addresses purpose. And what is this APIPA? I will explain it later. But class A, class B, class C are unicast address. So the IP addresses from class A, class B, class C, except few, maximum we can able to assign to the any device. Okay. Of course, there is a one more point is there that we will go. That is called a private and public IP addresses. So we'll see that one. Okay. Whenever you got an IP address, if the question is which class of it, which class of this IP address, check the first octet of IP address. First octet of IP address, like here in the first case, first one is 120, the second one is 151, and third one is 191, and fourth one is 224, and fifth one is 240. Okay, only first octet, not the second like a 9 or 200 or 1. So you don't, that is not point. It is a first octet. The range is cross verify with your class. Then it is a, we can get a which class of IP address it is. The next one is why we need to divide the IP addresses into the classes, because IP addresses are start with the IPv4 addresses start with the 0.0.0 to 255.255.255.255. Then it is a very huge range. It is almost like a 4.3 billion IP addresses. And we cannot assign each IP address straight to the devices, because IP address is not just an address, it is a, one second, one second, one second. Sir, sir, చెప్పండి. Okay, today class up to 4:30 only, guys. Okay, so we'll see small things. What are the left over here? So we'll complete. Um, um, yeah, the class is why we divide it into the different classes like a class A, class B, class D, class C. Okay, so if instead of assigning, if you are assigning one by IP address to devices, that is not okay, because the world population, worldwide devices, so entire thing should be communicate. So that is difficult. So what we are doing, IP address is a logical addressing. We divide a network into the logical way. We divide a network into logical way, like a network portion and host portion. Network portion and host portion. Okay. So network, like a host. It's a network part, host part of the IP address. So what is this network and host portion we are dividing using a classes based on class A, class B ranges? Like what is the advantage of it? So depends upon number of hosts in the network, we can choose that particular class. So for example, class C will give you up to 254 hosts only we can able to get it. So 254 IP addresses means 254 devices. Class B. So I can, if in case I have more than 254 devices, I will go for class B. 65,534 devices we can able to connect it in a single class B network. For example, you see it is a class A is around a 60 million host we can able to connect it. So the first portion of the class A is a network portion, and default gateway is 255.0.0.0.0. Okay, so that is class A. So see, this is the class A. So you take a 100 computers. 100 computers, you assign an IP address, but for all 100 computers, the first octet is same. First octet must be same, and these things can be changeable. These three can be changeable. Okay, these three can be changeable. So what are the these numbers? That is belongs to host. Anything. I have another host, maybe 10.20.4, 10.20.5, 10.120.16, 11.15.24. Like that, anything can be here, but this must be same for 100 computers or 200 computers or 500 computers. So it is up to 16 millions. Okay, it means this is same for a 16 million host. Okay, that is called a network portion. Remaining is a host. Host can be changeable. This is class B. Class B, network host. So like almost 65,000 IP addresses I am getting. It means this is the network part. This is host part. The host part 2.190 can be different for a different host, but for all hosts in the same network means 150.10 is the same for all the hosts in the network. For example, you take here, I have a pieces like a 150.10, right? So as I said, 150.10. So 150.10, 150.10, 150.10, 150.10, 150.10. It means all are in the same network. Remaining two parts can be changeable. Can anything. Should not be same, but can be anything like 2.190, 2.191, 2.192, 2.193, 3.150, 3.4.3. Anything can be in this two portions, but there are same network. So network portion must be same. This is class C, so the first three portions must be same for an entire network. This portion can be changed. It can be 1, it can be 2, it can be 10, it can be 20. Okay, so that is why we can easily divide into the network size, and we can create as a network and host kind of logic we are doing that. So it is called logical addressing. So here always guys remember, so you have two IP addresses, two devices are there or three devices are there. If you want to make a communication between these devices, their network portion must be same, or we can say network ID must be same. In this example, it is a class B 172.16.10.230, 170.16.100.12. In a PC1, PC2, two PCs with this IP address. And you got a question like whether they will communicate each other or not. Okay, so it is also troubleshooting. Both are having an IP address, but both IP addresses are in the same network or not. Check the network portion 172, 172, 16, 16. Yes, both are in the same network. And check the host portion are different, so that is good. And you see PC3. Again, 172, 172, 16, 16, same network. So PC3 also communicate. PC1, PC2, PC3 are communicate each other. PC4 don't communicate with anyone. Why? Because it is a 172, 172, good. But 16, 17, not good. It is different network. So network is different. Okay. This is also same thing. Just go through once and cross verify. I already shared this one. Already I told what is subnet mask. Subnet mask will tell what is your network ID. What is your network ID? Okay, so when two PCs are communicating each other, or when you are forwarding packet through router to router, PC to PC, any communication. First of all, you have to identify the network. How to identify the network? Based on the subnet mask. You are using a subnet mask that is called 255.0.0.0 for class A. Class B default subnet mask is 255.255.0.0 and class C subnet mask is 255.255.255.0. Okay. Why it is called as a default subnet mask? So whenever you enter an IP address into the IP address part in a adapter, you put IP address, then automatically it default subnet mask will take in. Okay. You can change if you change the subnet mask. Your network ID will be changes. Okay. The calculation based on the AND gate operation. I'm not going that one. So this is called as subnetting. What is a subnetting? Subnetting is a dividing an IP address into multiple subnets. You have a network. So can you see there is a network ID here? This is the network. If you want to divide this network into multiple parts, then it is become a one. Then we can able to divide like a two networks. This is one single network. Actually, this is a one single network. We can divide this network. Like means we are getting 254 hosts in this network. So out of 254 hosts, I want to divide like a as a two networks, or maybe four networks, maybe 8 networks, maybe 16 networks, maybe 32 networks. I can divide it by just simply changing the subnet mask. Here it is an example. Can you see here it is? This is the IP address. This is a subnet mask. And I calculated, I got a network ID like this. Means this is once, like there are a lot of things are there. I changed subnet mask and I calculated network ID. See the network ID different. Both are look like same, but subnet mask changes. Network ID changes. Only for idea, guys, not for exactly teaching part. Okay, so if you want learning networking subnetting concept, that is separate. Okay, so that's we are not doing that one now. If you are using a class, if you are using a default subnet mask, so this IP address we call it as a classfull. If you change the subnet mask, you use it some different subnet mask than a default one. So that type of network we call it as a classless. That type of network is called a classless. That type of network is called a classless. Means if you use the default subnet mask, for example, you said your IP address is 170.16.100.10, but you didn't tell the subnet mask. I have to assume you are using default subnet mask. That's why it is called as a classfull. For example, you are telling in your IP address 170.16.100.10. Okay, and but a subnet mask is different. The subnet mask is different. So compulsory you have to specify the subnet mask. Understand, guys? You tell only IP address. You didn't tell a subnet mask. So I can able to assume you are using a default subnet mask. So I thought it is classful network. So I assume this is the subnet mask. You are using a default one only. So then I will consider as a default one only. If in case you change the subnet mask, you put a different subnet mask. Okay, so then what you have to do when you are telling an IP address, but you are using different subnet than the original class, then you have to tell the subnet mask also. In this one, if you don't tell, I know it. But in this one, compulsory you have to tell, because I don't know what subnet mask you are using. I thought it is default, but you changed it, right? Like this. So this type of networks we call it as a classless. Sometimes it is not always okay to write full subnet mask. So we can represent a subnet mask with a slash notation. What is this slash notation? If we convert this number into binary, so those many number of ones you are getting, that is 250. That is we are writing here. For example, 255 means 8 ones. 8 ones. 8 bit, right? So 8 ones. 8 ones. 8 ones. Total it is 24 ones. That's why we are writing slash 24. That's why we are writing slash 24. So this is called as slash notation to represent subnet mask. It is also called as a prefix. For example, I am writing like this: 170.16.19./24. I think I didn't write that point here, so I will add that one. Yeah, he written here this one. Okay, here like this. This is the IP address. This is my subnet. Default only. This is default only, but I can write like this, or I can write like this also. If I write like this slash 24 called as a prefix. Okay. If you don't want to write complete subnet mask, either default or a changed one, okay, or customized one, you can tell either you tell like this, or you can easily tell by using slash notation. This slash notations representing like this. This is also called as a prefix. The method is called the method of representing a subnet mask in the slash notation is called a CIDR method. CIDR method, classless inter-domain routing. Because when you will specify a particular class, compulsory you have to tell a subnet mask. So when compulsory you have to tell a subnet mask, either is slash notation or maybe full writing of a subnet mask when if you are using different subnet mask than a default one, right? So that is called a classless. So that's why this name is also like this, classless inter-domain routing method. This slash n, that's the slash 24 represent 24 ones. For example, /8 represent 255.0.0.0. For example, there is a class A IP address is there. So for example, this is class B default subnet mask, right? So this is class B IP subnet mask. So you can put 8 plus 8 is 16 like this. So instead of that one, you can put a /16 also, /24, /25, /17, /18, /20, /23, /27, /30, /10. Different type of slash notations are also there. Okay, so you have to carefully count the number of ones. Based on that, we will get it. /25 means already 255.255.255 is there. So totally 24 ones. These three are become 24 ones. Then one more one will come here. 1 000 4 zeros. That in the binary 1 000 4 zeros. Then it is become 128. So this is the subnet mask. This is the representation of that subnet mask in the slash notation. Okay, so try to understand, guys. These are the different numbers. I said now 1 and the remaining are zeros. It's a 128, 192. Okay, for example, you see /20 means this is the way to write /20. Okay, see it is 8 plus 8, 16 plus 4. Remaining are zeros. See this is 0 zeros, 0 zeros. 20. 27. 8 plus 8 plus 8. 24 plus 3, 27. This is equivalent is like this. Okay. So once we are going to subnet mask, subnetting calculations. Okay, if you go in the future anytime, if you go or if you watch any further details, then you will understand. It is not right time and we have a lot of work to do it. Okay, but this is important. Okay, yeah. You guys understand subnet mask / representation. What is this?
Yes, sir.
Yes, sir.
Yes.
Okay, so very good. So then we will see the one more point that is called a private IP. Okay, what is this private IP? Okay, two more important topics in the IP address. It is one is a private IP. Subnetting I can't cover. So if very interesting people are there, then we have to take specifically. Not I am not able to. Like I don't force you to. You people should learn the subnetting concepts. I cannot force because it's a purely by practice you will understand subnetting concept purely by understanding, purely by practicing. You have to take the questions and practice, then only we can able to understand, you know. So before I joined to a job, like I came back to from there to Hyderabad. So yeah, a few days back, I mean 3 years back. So I went to the institute and I learned this subnetting part. And also similarly, my brother also while he's doing engineering, he's also learning CCNA. So he said some website. I took almost 2 months to practice all subnetting part. Okay, 2 months full sitting and only subnetting. Anytime, any question you give, and I will tell an answer. Okay, subnetting related. So later on days it will if you got any gaps, it is very quick review. I can able to get it. Okay, so I know how to teach, how to make a people to understand, but in the classroom that is not currently, it is not, it is we can't do. Okay, so here it is another part of IP address is private IP address. What is this private IP? It is a non-routable in a public internet. Okay, my PC having a my laptop having a private IP, which is came from which is I got it from my DHCP. It's nothing but my router. My mobile phone is also private. My laptop is also private. The desktop is private. Okay, all are private only. Okay. But to communicate in the public, you need a public IP address. So who will take care of this public IP is your ISP provider, internet service provider will take care of your public IP communication. Okay. So what is the use of this private? Your for example, you have that server A. You have a server A, and the IP address is private IP. Okay, and if you are in the same LAN network, you are in the same LAN network. It means you have another PC here. Okay, you have another PC here. Okay, you have another PC connected to a single switch. Okay, connected to a same switch only. Connected to a same switch. This is a some PC1. Okay, if PC1 want to access this server A, it is just the local IP is enough. So 192.168.10.11. Important is both are class C and both are first three must be same network. So both are in same network, both are private IP addresses, both will communicate each other in the LAN communication. But for example, I want to access, a remote server. I want to access a google.com. From PC1, I want to access google.com. Request go to router. Router is forward to your ISP. ISP do some magic and it will forward to the route internet, and finally will receive the packet. Will receive the packet from the google.com. Okay, we receive the packet. We can go outside. It depends upon router and ISP, the NAT technique, so they will make you connected. But if one, for example, some remote PC is there, want to access your PC, okay, or your PC or your server, they cannot communicate. Why? Because of you are in the private network. You don't know. Even if you know your private IP in this world, same IP address is there in a millions of times. The same IP address is repeated millions of times. Okay, 192 series is a one of the famous series anyway. Okay, so 192.168.10.80 or 10.11 IP addresses are there in this world million times. So your remote, your other PC in the internet cannot reach you by your private IP. Okay, so how we are communicating, we forward the packet to the router. Router will do NAT technique and it will forward the packet to the destination, and based on that we receive the packet up to ISP and ISP to our devices. Okay, guys, a small point here it is. I have a server, for example, it is a web server in my local network. I can able to access from here because of both are in the same network, both are in a physically, logically same network, no problem. Okay, someone want to access my server, okay, through internet. You want to get access to through internet, you want to get access. What you do, you must have a public IP address. So I have to purchase the public IP address and configure your IP to your configure to your server, and you have to talk to your ISP or a router, put that IP address into the public. Okay, so people can able to communicate to your server. You have a server and you have a public IP address, so then people can able to send request to your server through internet because you are having a public IP. If in case you want to hide it, for example, you try to ping to google.com, you got an IP address. Really, it is a google.com IP address. May not be. You want to hide your IP address. You want to hide your IP address. You want to use a private IP only. But in a public, when people are communicating to your server using a public IP, so what you have to do, buy a public IP address, configure your router as a NAT router, network address translation. Meaning is, if you got any request to this IP address, you got any request to this IP address, this router translate and forward to A. Yes. Okay. To A. Why? Because of I bind it like this. This IP and this IP are binding, link or mapping or mapping. So what happened? Someone is trying to access your server with your public IP. Your router received and translate and change the IP address and give it to server A. Okay. So because of it is a NAT. Okay. So this is how companies will do a basic NAT technique. But here I have written few things. So guys, these are the private IP addresses which you can able to configure to your PCs in your private network. You don't have to take any license or pay for a usage of these IP addresses. Next one is NAT and PAT. NAT and PAT. NAT means network address translation, maps internal IP address or inside IP address or a private IP address to external public IP. NAT is a one-to-one type, means one private IP or a one inside IP to one external IP address. For example, in this case, my private IP 192.168.1.11 in my public for the same IP only single host only. But in the public, it is different. In another PC is there, that is 192.168.1.12. Okay, that is the internal IP address. But when I'm communicating to public or from public to your PC2, so then they use a public IP address. So it is translated into 200.12.23.12 and send it. And when it is receiving, you received to 200.12.23.12. You received and again translate into 192.168.1.12. So it is a one private, one public, one inside others. For example, you have a 10 private IP addresses, 10 servers are there. So you need a 10 public IP addresses. Compulsory. If in case you are in the home, just you want to access outside of the network, but you don't want to get accessed, means you have a server, the server can be accessed to in an internal only. Server want to access from public, but I don't want to anyone can able to access my server. Okay, so okay, I don't want anyone accessing my server. Okay, so you need to put it in a public. So we use a port technique, port address translation. It is also called a NAT overload. It is nothing but a NAT only. Same thing, it maps your internal IP address to external IP addresses. So in this case, Okay, I have a three PCs, PC1, PC2, PC3. Three PCs, three private IP addresses, one single public IP address. In NAT, it is a one-to-one, means one private, one public. Here it is three private, one public. So that is called a NAT overload, also called as a port address translation. Why we call it as a port address translation? Because to map multiple inside IP addresses to outside IP address, it uses a port number. A random port number will be generated and attached. So then your pat function will be like so. Important pat, you can communicate to any PC, any device outside of the network through the public IP address using public IP. But if in case you have a server, you want to get access, you should buy a public IP address, okay? Or if you want to use NAT, then you assign a private IP address to your server for internal or intranet communication, and for public use, public network. That's it. The small thing is one more. It is APIPA, automatic private IP address. APIPA range is 169.254.0.0 to 169.254.2, 255.255. Guys, when you check your IP address, it is showing 169.254. Meaning is you got an error. Meaning is you got an error. So why we are getting this APIPA? Automatic private IP. Automatic. So means DHCP, dynamic. You will get an IP address from DHCP server. If you configure an IP address on yourself, that is static, manual. But you want to get an IP address from DHCP, obtain IP address automatically option. Obtain IP address automatically option. Okay. If your device is unable to get IP address from DHCP server, it can be DHCP server fault or network connection fault or client related fault. But if you fail to get an IP address from DHCP server, okay, then the device means your PC itself assign an IP address that is called APIPA. So every device should have a APIPA address. Sorry, every device must have an IP address. So at this point, again, guys, what is this APIPA? Automatic private IP address. When you see an adapter IP address range is 169.254.0.0, starting 169.254, first two digits are there like that, means it is an error. What is an error here? Whenever you are unable to get an IP address from DHCP, your system or a device will assign an will itself assign an IP address. There was a range, okay? So your device is unable to get an IP address from DHCP server, okay? So you will get APIPA. How to troubleshoot? First, check that DHCP server, whether it is on, off, busy, overload, okay? So these are all DHCP server check facts. Connections, physical connections also you have to check it. If your device is unable to get IP address from DHCP server, means you have to check the first DHCP server. Make sure it is working. Make sure there is a IP address available. Make sure it is must have a IP address availability, connectivity, service button, all these things factors you have to check it. Make sure DHCP server is working. Again, try to get an IP address. If you are failed to get IP, okay, you check the DHCP working, everything is fine now, and you're trying to my okay, so check the DHCP kind of stuff. If issue is resolved, okay. If not resolved, still it is showing 116. Your DHCP server is working, but your client is not changing the IP address. Automatically it should be changed. If not changing automatically, then disable and enable the adapter or use the command called ipconfig/release ipconfig renew. Okay, so this is called APIPA, guys, automatic private IP address. When you see an adapter with 169.254 means it's an error. When you are getting a self-assigned IP address, if you are unable to get an IP address from DHCP, then automatically the system itself assign an IP address in the APIPA range. Okay, we cannot able to communicate with APIPA address. So what to do? First check the DHCP server connectivity and other any software inside. So check that, make sure DHCP server is working fine. And connectivity, and also connectivity. So once you are done, so you will get an IP address from DHCP server. The error will be gone. If you are not getting like that, so still it is showing. So you can disable, enable your network adapter, or you can go to command prompt ipconfig/release and renew. So then it will remove the old IP and try to get the new IP from DHCP server. APIPA troubleshooting. Then unicast kind of stuff, right? This is the OSA model. We are already discussed the OSA model. I don't know how many people are understand, but it's okay. Last time we discussed. It's a 4 o'clock. What we have to do? 1 second. Yeah, guys, take a break. Take 10 minutes break.